Have you ever looked up at the night sky and just wondered what's out there? Our home, the Milky Way galaxy, looks like a calm, glittering river of stars stretched across the darkness. But if we had eyes that could see a different kind of light, a much, much more powerful light, we'd see that the center of our galaxy isn't calm at all. There's something strange happening there. Deep in the heart of the Milky Way, there's a huge, mysterious glow. It's not visible light, the kind our eyes see. Instead, it's a bright, fuzzy ball of high-energy gamma rays discovered by special space telescopes. Scientists call this the Galactic Center Excess, or GCE, and it's a cosmic mystery that has everyone buzzing with excitement. So, what are these gamma rays? Imagine light as a spectrum, like a rainbow, but much, much bigger. On one end, you have low-energy radio waves, and on the other, you have incredibly high-energy gamma rays. They are the most powerful form of light in the universe, packing millions of times more energy than the sunlight that warms your face. Our planet's atmosphere protects us from them, which is, a very good thing. To see these rays, we have to send telescopes like NASA's Fermi Gamma-ray Space Telescope into orbit. These instruments act like our special gamma-ray goggles, showing us the most violent and energetic events happening across the cosmos, like exploding stars and maybe this strange glow at our galaxy's core. This glow, the GCE, is a puzzle because there's more gamma-ray light coming from the galactic center than our current models can explain. It's like hearing a loud hum coming from your basement, but you've already accounted for the furnace and the water heater. There's an extra source of noise, or in this case, energy, that we don't understand yet. This isn't a small discrepancy. It's a significant, persistent signal that has been observed for over a decade. In this cosmic whodunit, we have two main suspects. The first is really exciting: dark matter. What is dark matter? It's an invisible substance making up about 85% of all the matter in the universe. We infer it from gravity tugging on stars and galaxies. Like the wind, which you can't see, makes leaves dance. It doesn't shine. It doesn't reflect light. It doesn't appear to interact with us. One popular idea: two dark matter particles collide. They annihilate. A flash of energy. A shower of particles, including gamma rays. Diagram of two dark matter particles annihilating and producing gamma rays. This makes the GCE tantalizing. The glow sits where we expect dense dark matter. Theory says dark matter is densest at galaxy centers. Think of a dense fog that's thickest in the middle of a valley. Annihilation signal would peak where the gamma-ray excess is. If true, this would be the first direct detection of dark matter. A Nobel Prize-winning physics-changing discovery. But there's an alternative suspect: pulsars. What's a pulsar? A super-dense spinning core left from a supernova. Imagine a star much bigger than our sun collapsing down to about the size of a city, yet holding more mass than the sun. They spin hundreds of times per second. They emit beams of radiation including gamma rays from their magnetic poles, like a lighthouse beam sweeping past Earth, producing pulses. They are cosmic lighthouses, blinking regularly. The pulsar theory says the GCE isn't one big fuzzy glow, but the combined light of thousands of faint pulsars that we can't individually distinguish. The galactic center is both a stellar nursery and a graveyard. It's had billions of years to accumulate stellar remnants. So it's plausible the center teems with pulsars. Each adds a tiny gamma-ray contribution, and together they mimic a diffuse haze. No new physics required. We know pulsars exist, and we know they produce gamma rays. The key question: are there enough of them in the right place to explain the entire glow? To solve this mystery, scientists have to act like forensic investigators, carefully analyzing the light from the galactic center. They look at the texture of the gamma-ray glow. If the glow is from dark matter annihilation, it should be perfectly smooth and diffuse. Imagine a fog machine filling a room with an even, unbroken haze. However, if the glow is from thousands of individual pulsars, it should be a bit clumpy or grainy, even if we can't see each individual point of light. Think of a sandy beach from far away. It looks smooth, but it's really made of tiny grains. Using advanced statistical methods, recent studies have tried to hunt for this graininess. A few research teams, poring over years of data from the Fermi telescope, found evidence of faint, point-like sources hidden within the larger glow. They identified a subtle blotchiness in the gamma-ray map that matched expectations for a large population of unresolved pulsars. This finding gave a big boost to the pulsar hypothesis. It suggested we might not need a mysterious new particle after all. However, the case isn't closed. Other teams have pushed back, arguing dark matter is still in the running. They've developed more sophisticated galactic center models, accounting for complex gamma-ray production and interactions. Some studies show dark matter models can still fit the data, even allowing some clumpiness. They argue dark matter and pulsar signals can look very similar, making them hard to tell apart with current instruments. The cosmic fog might be thick enough to hide the true source. What if it's both? The Galactic Center Excess could be a composite signal. Perhaps a portion of the glow comes from dark matter annihilation. Perhaps the rest is produced by a large population of pulsars. The galaxy is busy. Multiple phenomena can happen at once. Science will test each component, measure how much each suspect contributes, and build a more complete, accurate picture of what's really going on. One of the biggest hurdles in this investigation is the location of the crime scene itself. The center of the Milky Way is the most chaotic and visually obstructed region of our galaxy. It's like trying to find a specific person in the middle of Times Square on New Year's Eve, but during a thick fog. Millions of stars, dense clouds of gas and dust, a supermassive black hole. This cosmic clutter creates a tremendous amount of background noise. The dust, in particular, blocks our view in visible light, making it incredibly difficult to see the galactic heart. So we rely on other wavelengths, gamma rays, radio X-rays. That crowded environment makes it tough to distinguish one signal from another. Gamma rays come from many processes: dark matter, pulsars, cosmic rays smashing into gas clouds. Teasing out the faint GCE from all these sources is monumental. Scientists build detailed models and subtract known sources from maps. The GCE is what's left over. Small background model errors can change the leftovers' shape and intensity, potentially favoring one explanation over another. The two suspects are hard to tell apart. Dark matter annihilation signals. Many millisecond pulsars combined. Both produce gamma rays in similar energy ranges and distributions around the center. Cosmic impersonation. Gamma ray data alone might not be enough. We need another line of evidence, a smoking gun. Scientists are looking beyond gamma rays. Researchers are using a multi-messenger approach. Different telescopes for different signals. Radio telescopes excel at finding pulsars. A deep radio survey of the galactic center finding thousands of unknown pulsars would strongly support the pulsar hypothesis. Particle physics experiments on Earth, like the Large Hadron Collider, are trying to create and detect dark matter in the lab. If successful, those results could show whether dark matter annihilation matches the GCE. Well, that's the challenge. So why does this cosmic whodunit matter so much? Because either answer leads to an incredible discovery. If the glow turns out to be from dark matter, it would be one of the most profound breakthroughs in the history of science. It would confirm that the vast, invisible substance that holds our universe together is not just a theory, but a tangible particle we can detect. We would finally have a window into the dark sector of the universe, opening up a whole new realm of physics. It would be our first direct conversation with the 85% of matter that has remained silent for so long, teaching us about the fundamental building blocks of reality. On the other hand, if the glow is proven to be from a vast population of pulsars, that would also be a fantastic discovery. It would reshape our understanding of stellar evolution and the history of our own galaxy. Finding thousands of millisecond pulsars at the galactic center would tell us a rich story about how stars are born, how they die, how their stellar corpses congregate in the densest part of the galaxy. It would provide an unprecedented map of this extreme environment and help us test our theories of gravity and matter under the most intense conditions imaginable. There is no boring answer here. For now, the glow at the heart of our galaxy remains an unsolved mystery. And that's a wonderful thing. It's a puzzle that we can investigate with real tools and real data. It fuels our curiosity and drives us to build better telescopes, design smarter algorithms, and think more creatively. This is science in action. It's a process of proposing ideas, testing them against evidence, and constantly refining our understanding. Teams of scientists all over the world are collaborating and competing, checking each other's work, and pushing the investigation forward, one paper at a time. The answer isn't just going to fall into our laps. It must be earned through patience and ingenuity. Ultimately, the story of the Galactic Center Excess is a story of hope and wonder. It reminds us that there are still great mysteries left to explore, even in our own cosmic backyard. As we continue to point our instruments toward the galactic heart, we are not just looking for an answer. We are participating in the grand human adventure of exploration. Whether the culprit is the elusive dark matter particle or a hidden city of spinning stars, finding out will tell us something new and amazing about the universe we call home. The clear takeaway is this: the universe is full of secrets, and by asking questions and searching for answers, we get to uncover them, piece by glorious piece. That's why it matters.